In this lesson, we're going to add crosswalks at the ends of our roads where the lane markings end. Both here on our four-way intersection and also at the end of our T-junctions. Here. To do this, we're going to create a crosswalk element which we'll then instance at these specific places. To do that, we're going to need one of our road curves, and it'll be our straight road curves for our crossroads. So let's add a reroute node and hit Ctrl+G to group it into its own node group. Just like we've done before. We'll rename the inputs and outputs. We'll be outputting instances. And the input is a curve class. Let's make this node group a little larger. And we're going to call this period crosswalks. Again, starting with a period, so that it doesn't appear in our group menu or app menu. We can connect our instance to the join geometry. And I'll just add a reroute node here to keep things tidy. So let's move on to our crosswalks. And the first thing we want to do is trim the curves to the point where we want to instance on. Just like with the lane markings. So we'll add a trim curve. We'll set it to length. Just like earlier. We'll need the named attributes road widths. We'll need our spline length. We're going to subtract the road width from the spline length. Plug these into the start and end. But I also want to add a small buffer, so we're not instancing right on the ends. So I'll add a note. Just duplicate this subtract node. And that now gives me an extra length I can add or subtract from the road width to include in this. So I'll set it to 10. We might adjust it later. But I think 2 will be okay for now. Next, we want to convert the curves to points so we can instance on them. So I'll go CTP curve to points and drop it over the top. And if I take a look using wireframe, let's preview the points directly. You'll see we're getting a lot of points per curve. That's because the count is set to 10. It's giving 10 points per spline, which isn't what we want. We could set the count to 2, so we only get the start and end points. Or we could just switch to evaluated, which will only generate points at the original control points on the curve. We don't actually have to convert them to points. You could instance directly on the control points. But using this method gives us extra outputs like the tangent, normal, and rotation completely free. And we won't need to calculate anything else. That's going to be super useful when it comes to aligning our instances. Speaking of instances, let's build our crosswalk element. I'll start with a grid, and let's view it. Just simple. We don't need a 3x3. We can just use a 2x2 grid. We want this grid to match the road's width plus some buffer room. So let's get our road width. But here's an issue. We can't plug our road width into the grid because this one is a diamond socket. It's an attribute, and the grid is expecting a single value. The way we solved this before was by creating a for each loop to analyze each spline individually. But that won't work here, because we're not analyzing or skinning any splines or creating curved mesh. We're trying to make brand new geometry. So instead, we'll use a sample index node. If we connect our attributes to the value input and sample our cross curve, which has the attribute road widths on it, by sampling just a single index, the output value will be a single number which we can now plug into our grid. So we'll set the grid to be the width of our crosswalk, plus probably a bit more. Let's add a math node. You might need to adjust this again. We'll set this to 1. And then, we may tweak it later once we've instanced them. But we'll look at that shortly. And how wide do we want our crosswalk? Let's say 3. To create the kind of bands on the crosswalk that look like this, we'll do it in the shader editor, just like we did with the dashed lines. That means we'll need to unwrap it. But on our primitives, we already have an output for the UV map, which we can simply store. We'll name it UV map, as we've done before. A 2D vector on the face corner, we can plug the UV map directly into this value. Just make sure to call it UV map. Now let's instance our crosswalk onto the points. So delete the view node. We're going to use an instance on points node. So I hope I don't. And we're going to take our crosswalk elements and drop that into our instance. So a couple of things. First, we're getting a little bit of Z fighting, which we'll fix shortly. It looks like our crosswalk element is just big enough. Maybe we want to add a bit more buffer to it. So I'm going to bump that to 2. We're also seeing some Z fighting not just on the road, but also on the sidewalk. So before doing anything else, I'll go out of our Crosswalks group, head over to our Sidewalks and Pavers node group, and on the sidewalk profile, let's just, adjust the position of that sidewalk profile. We'll add a bit of extra height. So apparently not on the Z-axis, because that's not what we want. It's probably the Y-axis. So let's just increase that a little bit. 0.02 removes the issue. That looks fine. Let's exit from that and go back to our crosswalks. Let's fix that Z fighting. Now let's extrude our mesh. Obviously, we don't want it to be that large that looks pretty insane. So untick individual to start. And how tall do we want this? 0.01 should be fine. Yeah. And that way it's not overlapping with our lane markings either. The next issue is that these aren't oriented correctly. They all have the same rotation as the original instance. But this is where the rotation output from our curve to points node helps. We can just plug the rotation into the rotation. It looks like they've disappeared, but they haven't, they've just flipped sideways. But at least now they're oriented correctly along the x-axis. So all we need to do is rotate our instances. I'm going to leave this in local space. And we're just going to rotate them 90 degrees on that local x-axis, which now aligns everything correctly. Next, we just need to assign materials to our crosswalks. So we'll set the material. We're going to need a new one. So let's go up to the shader and load a new material called B-City Crosswalks. We'll make sure to assign that in our geometry nodes. I'm going to take texture coordinates, split them into X, Y, Z. We'll take a look at those. That's looking correct, because we already made sure to store our UV map from the grid. Now we can do the same as we did for the dashed lines. We took these, and we'll start by adding an offset. We'll apply a modulo operation with a certain value, and then we'll compare whether it's greater than another value. So first, modulo by 0.1 with a threshold of 0.05. Looks good. We can also offset these however we like if needed. So now all we need to do is use that to drive a transparent effect. In fact, we don't really need to do anything fancy with it. We can just plug this directly into the alpha channel. So let's do that connected to alpha. Leave everything else here. Then we'll increase the roughness. And now we just need to give the crosswalk a yellow color. So let's set this. I think that works. And now we have our crosswalks. At this point, one thing we should continue doing throughout the process is debugging. And once this looks fine in its current state, if we go into edit mode and extrude out an edge, this looks okay. But what's happening here? These crosswalks and lane markings are getting messed up. The reason is if we stop and think about it, what's happening in our crosswalks group is this. We have a curve coming in, and we're trimming that curve. But if we look at it, this should be split here and trimmed at those points. But it's not. And that's why, when we convert it to points, we don't have 2 points here. We only get 1. So we need to make sure we split these edges. It's something we wouldn't have noticed unless we started playing around in edit mode while building these. So it's really important to constantly adjust slightly and test the mesh, so it works in all situations. So how can we solve this? Well, let's exit our crosswalks and look at the input curve coming from the cross curve here. We need to make sure that each edge or curve is its own separate spline. The easy way to do that, if I delete the viewer node and move this over, I'll just add an extra reroute here, and we'll use the duplicate elements node. We discussed this when creating our lane markings to duplicate separate elements. Let's view it. Plug our input into duplicate elements. We're duplicating the edges. Now let's view this. If we check the spreadsheet, we'll see we have 8 edges, which is right. 1, 2, 3, 4, 5, 6, 7, 8. And if we mute it, we have 9 vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9. If we unmute it, now we have 16 vertices. Each edge has 2. It's now split from the rest of the mesh. If we convert this to a curve and view it, so trimming works, regardless of whether they were previously connected. That's why it's always important to debug the mesh as you go. In the next lesson, we'll be adding traffic lights to our roads and begin building the rest of our road instances.